Today is the last lecture of the programming course, and I think we might be rather quick because we don't have that much content this morning. But we start with a important topic which you can use in your project. It's about tests, exceptions, and assertions. So you can test your code. You know what to do with exceptions if they're raises. I think you imagined some while coding. And what are assertions? So what you may recognize that your code can include some bugs. So bugs are mistakes inside your code causing undesired behavior or errors. So, and it's pretty normal that you don't write well working code at your first attempt. It's not that often, even in much more complex projects. So what happened is that errors occur or your code does not work as intended. So you have to do something against this, that your code does what you want to do. And to prevent bugs, you need to start testing your program at an early stage and to make clear that everything works fine and everything works as you want that it works. So to prevent bugs, you can use some techniques, which is defense programming. On one hand, this means that you write specifications for your functions. So to write down what should your function do, how should it behave, and what should be the input, what should be the output, as well as to modularize your program, which makes it a lot more easier for you to figure out where a bug appear or where an error occur and to clean it up. And to do so, you can test your code. So you test code snippets or test functions. And then while testing, you compare the input and output to your specification. So you want to know you have to know what's the output, and you want to compare the expected output with the result of your function you wrote. Another technique is debugging. Debugging is to study your code step by step, go through it once in a while, and to look up when does an error raise. So we now look a little bit more detailed on these ones. So testing is pretty important. So you can start testing even after your program is able to run. So this means there's no syntax error or static semantic errors, so that you can run your code and you become an output or something happens. So for PyCharm, it's pretty cool. PyCharm shows you these errors, so no syntax errors and static semantic errors, so that you can run your code after PyCharm says, okay, it's cool. And to test, as I mentioned before, it's pretty important to have a set of expected outputs, so that you know what your function has to do and how the output should look like, so that you can try to make this output to run. So, for example, if we have a function, let's wrote a little function to sum up two absolute values. So make x and y. And to sum up two absolute values, you want to have to look if even one of these values is less than 0. And if this is so, we have to assign them to x multiplied with -1. And the same for y. So 0. Okay. Okay, and after that, we want to return x plus y, for example. So this is our function we wrote before, and we want to test if this function is correct. And so we have to try out some values for them. So if we know what we want to look like, absolute value of, I don't know, 1, 2, and 3, we know that 4 must be the output. So after that, let's print this out. Print. And there it is, 4 is the output, for example. So if you want to look how another print statement looks like, -3, 4 should be the output as well. So we have to have a set of expected outputs, what you can check while testing. And it's pretty difficult to test everything. This is even not that possible, even for more complex programs, to test everything what can happen. But what you can do is to test for boundary values. So even for 0 or empty lists, for example, something where you can think, or that can be narrow, that can raise narrow. So for tests, you can write some unit tests. So to test your functions separately. So if you're coding, you write multiple functions and use multiple functions in your code, but it's recommended to use to test each function separately to make sure that the function is doing that what you want for it to do. So what you can also do is regression tests, what means that you're testing for bugs as they appear. So you write your code and write your functions, and even if a bug appears, you try to test it out and want to redo this bug and try to figure out why this bug appears. And you can make integration tests, which means that you prove your whole program at the end, which is even much recommended to prove that your whole program works as you intended it, as you wanted it to work. Okay, so there are some other approaches of testing. So you can use your intuition. So you can look up to your code, you may understand your code, and you can try to figure out what is not working in your code. Sometimes this can be pretty easy if you look it up and see if you have, even if you forgot the minus at this point, and you can try to check it out and see at the first sight, okay, the minus is not even there where it should be. But you can also write random tests, so you can be sure that parts of your code is correct. So if you know that parts of your program are working correct, you can decrease the probability that other bugs appear in your code in other places. And as well, there are black box and white box testings. So, and black box testing is to look at the specifications of a function. This means that this can be done from people which are not the developer of the code, because the developer know the code inside and know what should happen. But other people who are not even familiar with your code, they only try to use your code and want them to this works. This you do even after a program is finished completely. So if you, for example, have a user interface as maybe for your project or something else, you can use some random person to try everything out what can be able to do. And after that, they can write down what didn't work for them, and you can look it up and try to figure out why this didn't work. So for our example, this means that we do not look inside this code for this function. So you do only look inside the function. So you only use function without knowing what's happening inside it. And you only know, okay, there should be the absolute number, the absolute sum of two values. Well, okay, yes, what you should also do as well is to repeat these black box testing after you changed your code internally. So after you changed it internally and made some changes to your code, this should be repeated so that you can make sure that your code works as intended again or now. Okay, for white box testing, this means that you test your code while directly looking into your code. And this means you go step through your code and make sure what should look like, what should happen, and try to test it out. So you go through the path of your code, and it means that if you tested every potential path at least one time, it's called path complete. And if your whole code is path complete, you can say that it works. But there's also the danger of this technique that you miss out some code paths, which may be not good if you have other values to use. And if you're going through loops, you go through loops many times if your code works at this point. What you could also do for debugging, this means that you go through your code step by step. So for this function, if we debug this function, we have a 1 and 3, for example, and x is 1, y is 3. So for debugging, at first you check if x is less than 0, and as x is 1, this is false. So you go a step further, and as y is 3, so 3 is well bigger than 0, you skip this point again, and you just return 1 plus 3, which is 4. So this means that you go step by step through code and look what happens if you have some values in it. And this brings you a high learning curve. So because you understand your code pretty good at this point, so because you're going step by step through it, you learn your code much better and how it behaves with values you use. Before you just use some variables and try to figure out what should happen. But if you go step by step through your code, with real values, you know how it works and how it behaves. So debugging you can do inside with PyCharm. So there's a tool to debug your code. I can show you it later. Didn't open PyCharm right now, but you can also use some print statements. And print statements are just, how we did this the same time with the print statements. This means that we can at this point try to print out what is x and what is y to look how it behaves. So what happened after we make the absolute value. And print statements, as we did this even much often, are simply checking for variables or simply printing out what a variable is at a simple point. So good places to use these print statements to figure out where can a bug appear is if you enter a function and if you check for your parameters and if you check for your result, or if you check even before your result is going out. So you have to, you can use the print function wherever you think the bug has to appear, and then you can check if the value you use is this value you want to have at this point. So if we made a mistake and it forgot to make the -1 at this function, we just have our sum of the absolute values. And if we now try to use this function, we can, if we don't have the print statements at this point, we become -2, which means that we have 1 at this point, and with -3 we summed up -3, which is -2. But if we now have these print statements, we can check for y and x. So, and now we see that x is 1, how we want it to have. And if we want to check it much more clearer, we can look about -1, for example. So this should also result in 4. And if you look it up, we see, okay, for our x, this worked as well. This worked how we want it to work. -1, the absolute value is 1. But for our x, this didn't work as intended. So then we can look it up and see, okay, the -1 isn't there at the point, so that just couldn't work. Okay, and so we did it after that. So we printed, we made another print statement of your function result. This is another part to look for functions. So if we didn't print this function, so we don't even know. If we make no print functions, or we don't even know what happens. So just here because it's it's the command line. But if we make another thing, say x equals 5, we don't even know what happened at this point. So for this reason, we make print statements, even in a PyCharm environment, to look up for variables and what they are at specific points, and to look about what are these values and what should they rent as values be. Okay. Are there any questions for testing? So if you feel free to ask some questions as always, but if not, can go on with errors. And I think you saw errors often while coding. This is pretty common. And these are some examples for errors. So if you have a list which has 3 values, 1, 2, 3, and we want to access a 4th value, this is not possible. So we become an index error at this point. So we have an index error because we have only three values. Even for 3, we become also an index error because we start at 0, as we all know. This is an index error which happens often if you have while loops where you go iterate over a function and you did iterate one time too often. The other error is if we mix up types, so which cannot be operated together with an operation. So if you want to have hello divided by 5, this is not possible because you cannot divide a string by an integer. So there you also become the message that you used a string and tried to divide it by an int, which is not possible. Another example for errors if you don't have a variable referenced at a point. So if you use a variable, but this error is also showed up by PyCharm. So this shouldn't appear that often. But if we want to make this at this point, we want to try to print a value, we don't become a value because a is not even defined. Okay, and as well there are syntax errors, which are also showed up by PyCharm, which is pretty cool because it's where we have to look up for such errors. But if you want to print something and you didn't even close brackets or something else, you become a syntax error because the program cannot compile your statement at this point because it didn't finish at this point. Okay, but there are even more errors, error messages, but most times they are pretty clear because you have an error message in it and you see where the error raises and why this error appears. What you can do, what to do with errors. So there are some techniques how to behave with errors. So if error raises, you can let them fail silently. It's a technique how to skip if error appear. So if you don't care about that this error appears, but this is not recommended because your code should run clean without errors because it's not recommended that you raise errors sometimes and have to fail silently. What you can do as well is to return a customized error value if you don't want the program to interrupt, but to see when an error occurs. The problem for this is that it's hard to identify which value to choose for an error value, because in a program there can be much values, and sometimes a value appears which isn't the error value, but you thought this is an error value because it's the same value, and there you have to be a bit careful. So at this point, this is also not recommended. But what is recommended is to stop your execution of your program by raising an error. But you can also raise a specific error, so raise an exception and say why. So typically the error message to tell the developer what happened and why happened this error. And you can do this with these try statements. These are try blocks. And what you see here on the right side as a try statement, or a block of code. And under this try statement, you have these except keywords. And after these except keywords, you can write down a error. And if this error appears, you can behave on this error. So do as well. So let's type this out, and I can show you what I tried to say. So we want to have x and epsilon printed into up, and we will need to type them in. And again for y, it's a little bit more quicker. So we have x and y, and then we want to have one number and another number. And then we want to print out what's the divided by y. X divided by y equals divided by y. So, and for this, so we can make these input statements, and we don't want the program to stop this point. We want to make the program running again after this happens. So if we just we put this one in our code and we type something wrong, our program stops and says there's an error. This can be done furthermore. But if we try this block out and then we make sure what happens after an error occurs, so we can make except value error, and value error appears if we type in non-valid no number, instead a string, for example, which is not convertible. We just only want the developer to notice if we try to print out and say this wasn't a valid number. But there can be other exceptions. So there can be exceptions if you type 0 for y. This can be done as well. So because you are not allowed to divide by 0, you make a 0 division error. And tell the programmer that you cannot divide by 0. And if we leave after except, if we leave this out, if we do not specify the error for this and only write down except, this except statement will be executed every time an error appears. So it doesn't matter which error appears, it's getting executed at this point. So at this point we don't know which error appears if another error appears. So we have to say something else went wrong. Went wrong, exclamation mark. Okay, and we now want to try to execute this code. If we have our x, which is at this point we want to say this is high, so we now try to make an exception, so we cannot divide high by another value, and we have to directly become the error message. This isn't a valid number, because in the input statement we try to convert our value. And this is a string which cannot be an integer, so we become an error. And after the error raises, the except statement with the value error is showing up and is executed, and we become this print statement. And if we have numbers, so we now have 10, and we want to divide by 0, we become another error because we cannot divide by 0. Okay, and if we do something special, something else which I'm not sure if this exception statement will be working, but Yeah, if something else happened, this would be executed, and you see, oh, something else went wrong. There should be. I'll have to look up what happened at this point, but your program doesn't have to stop. And what's not so recommended, what if you fail silently, which means that you leave these statements out, for example, and you don't even know why the error raises. And to make some messages to show you what happened and what was wrong makes it a lot easier for you to figure out where your bug appeared. Okay. What we have now is another keyword, which is called finally. And again, after your accept statements, you can use else at this point, which means that if these accept statements are not executed, the else statement will be executed after your try block. This means, so we have at this point, let's make this example. I can show you a little, wait, let's make it a little bit more structured. So let's say we have a variable, it's called s. And with this else statement, this statement will be one if the accept statements are all skipped. So if we have one accept statement which is executed, we don't execute the else statement. But if every accept statement, so if our code in the try block is correct, the else statement is executed. So, and at this point, we just want to say s equals true. True. And with this finally keyword, finally is a keyword and which is once every time. So this block once even if anything happens. So this should be used if you want to finish something, if you have to clean your code up at the end, no matter what happened. If an error raises, if no error raises, no matter what, this code block should be executed. This can be, for example, useful if you have files, if you're working with files. And if an error raises, you do want to close the file at the end so it doesn't stay open. So then finally, you can then make some code or avoid some code which should be executed every time, no matter what. So for this example, we want only have a message if we were successfully or not. So if it is true, we want to write down the program was successful, finished successful. And if not, we want to show up that didn't want successful. So program finished with an error. So this code, so this code block is executed no matter what happens in this code blocks. So we always know if our code was good or not. So if you want to now try it out, and we have the same things than before. So let's write down high for x. We just have this wasn't a valid number, so we came into this accept statement, and we have the message the program finished with an error at this point. And if you want to try to divide by 0, we come the error message that we cannot divide by 0 and that we've finished with no error. But if we just did something right and we write down 10 divided by 10, which is 1, and we go into this else statement because none of these accept statements are executed. So our s is true now, and if s is true, we finished successfully. So we now did finish successfully at this point. Okay, so this finally statement even is going executed after a break, continue, or return statement. So if you have a function in it and you write down a function, if you have here, let me do this at the beginning, if we now have here a finally, this will run again. So even after you return something, this finally block will be executed immediately after this one. Okay, is there something else? No matter what happened. No. We come now to assertions. And assertions are some code lines inside your code where you can check for values or something else. And these assertions raise assertion errors. These are customized errors for you and where you can check for values. And this is inside your code, and you can spot bugs pretty early while you're checking for your variables unless the code is running. And this is part of defensive programming, so to check pretty early about your values and inside your code at the beginning. And you do mostly use this to check for inputs or outputs of functions, just to avoid unexpected values or undesired behavior. And to do this, to make something like this, we can now use again a function, summation of x and y. We can use, and then we can just use the keyword assert. And if we use assert, then this will be tried out. And we then firstly have to write down what should be checked. So if the type of x is int, so if this statement is wrong, as this is false, the assertion error raises. So this means after that we want to make an error message which says x needs to be of type int. And the same thing we want to check for y. Not x, instead y. And again, if this is false, we raise the assertion error. And after we checked the types of x and y, we can return the sum of them. So, but if we now try to sum with this function a float or an integer, we just say sum int 0.0 and 4, we become an assertion error. And the assertion error says, printed out our message, which says x needs to be of type int, and it shows you where this error happens. And we at this point from this function. And the same can be done for y. If we have 3 and 4.0, we have again the assertion error where it says that y needs to be of type int, so that y is false at this point. But if we make nothing wrong, if we made correct, we become our output and our program doesn't stop. Our program runs till the end until we can return 3 plus 4. Okay, this is about our assertion errors. So if these, where is it? Here, if the assertions are true, so if this one is true, nothing happens inside your code. But if we cannot meet this condition, we raise the assertion error. Okay, so this was it for exception handling, and this was the last issue, last topic of this course. There are 2 more slides where I want to show you 2 other programming languages so that you can see there's not only Python, so there are other ones. There are many other ones, but as an example, I want to show you Java, make a little overview about other programming languages. So if you have questions, feel free to ask, so we can go into detail for some things. But if you don't have questions, we can go on and finish this lecture. But there are two other programming languages I want to show you, which is at one side is Java, which is very popular programming language, which was at least for the last years one of the most popular programming languages, which is object-oriented, as well as we did it for Python. So we have data as the attributes for objects, and we can use and manipulate this data. But Java can be executed on every operational system. This means you don't have to only can use this on well, I don't know, Windows, Linux, or whatever. You only need an appropriate JVM, so Java Virtual Machine, where you can run your code. And the drawback of Java is that it's relatively slow compared with other programming languages, because in Java there's important focus on compiling and linking and before. And this is not the case for another programming language, another popular programming language, which is called C. But C is pretty efficient and pretty fast, even much faster than Python for at runtime, because there's no compiling. So the program does not check if everything is correct. So the program does not check about types or something else, which should be wrong. Right. So if something is wrong, you become undesired behavior, but undefined behavior, which is not pretty cool for you. But if you're good in programming, you can use C, and C is mostly also used for low-level activities, which means you can use C pretty good to program, for example, on machines. So program things where hardware is going into. So you can make bitwise operations, which is pretty important for machines, for programming machines in detail, or hardware in detail, for examples. Okay. In task C, we are supposed to implement diagrams. Can we also use static files for this, or images of diagrams? Yeah, why not? Sure, if it makes sense for the data, why not? So you don't have to only. So you can use the data. You have to use the database, but you don't have to. They can be static as well. This is no problem. But you have to make sure that you have other operations that you can. If the database changes, you should try to make sure that these diagrams will change as well. This would be pretty useful even for running program at the end. Okay, so this was the last lecture. We were pretty fast because we didn't have much topics to discuss. This will don't have furthermore in detail, but this is also well. If you have some questions about organization of a project or something else, you can try to ask right now. But there will also be the exercise courses today and on Thursday. And after that, after this week, there will be exercise courses as well. But we try to make this, if you want a exercise course or you have the desire of something like this, because you have questions about the project, for example, you can ask for help, and then the tutors coming online and try to help you, so they don't have to sit down there and be online for 1.5 hours and no one attends. So then you can just, they are ready for you if you have questions, but they're not online at this point. So you just have to ask and say you have questions, and they can help you face to face if you want this. Okay, I just want to wait 5 minutes to see if you have the questions about anything about the course, anything else. And yeah, after this we can finish this lecture. Yeah, just waiting 1 minute. I don't think that there are some questions, that there are coming any questions. So you have, it's still 2 months to prepare the project, which is pretty long. So, but try to start early, which can be helpful even if you have to write some exams, so that you can finish this even before. But we don't want the presentations of the project inside your exam time, so this will be afterwards. I hope this helps for you to focus on your exams. But if there are any other questions coming up preparing the project, just ask our tutors, which can help you as well. And so if there are no questions left, I want to thank you very much for attending this course, for attending the lecture. There will be no lecture next Monday, so you can focus on your project and anything else you're studying right now. So have a nice week and goodbye.